Welcome everyone. This is our first Python session. I'm assuming you have no background at all. We're going to start from the absolute basics. We'll build a strong foundation together. By the end of this series, our goal is not just learning syntax. I want all of you to build and deploy a small Flask application. We'll also use GitHub Actions to automate your workflow. But to get there properly, we first need to understand how Python thinks. In this first session, we focus on a few important ideas: how to run Python, what expressions are, how variables work, what strings and numbers are, how Python handles types, how to display output, and how to use conditions. We will also look at loops. When you learn programming, think of Python as a new language. It has syntax and meaning. Syntax means writing code that Python accepts. Meaning means writing code that works. If you make a typo, Python raises a syntax error. If the logic is wrong, the program gives the wrong result. Both are normal parts of learning. Python code runs in two main ways. You can run commands line by line, or you can save code in a script file. In this notebook, we will use the interactive mode. It's great for quick experiments. Since this is a beginner session, focus less on memorizing every detail and more on building your intuition. Ask yourself, what is the input? What is the output? What is the operation? Python can act like a calculator. If I write arithmetic expressions, Python evaluates them and gives me a result. This helps us understand that code is often just a structured way of telling the computer how to combine values. As we go through these examples, notice that operations such as addition, subtraction, multiplication, and division behave mostly as you expect. Also, notice that Python follows order of operations, and parentheses help us control that order. I also want you to notice commits. Anything after the hash is ignored by Python. This means comments are written for humans, not for the computer. Good comments help future you to understand what your earlier code was trying to do. You will also see that dividing by 0 gives an error. This is important. Errors are not a sign that you are failing. They are part of the conversation between you and the programming language. Python is telling you what it could not do. When you see an error message, do not panic. First read the type of the error. Then read the line it points to. Over time, this becomes one of the most valuable problem-solving skills in programming. Next, let us move to variables. A variable is simply a name we give to a value. Instead of repeating a number again and again, we store it in a variable and reuse it later. This is where programming becomes much more powerful than a calculator. A calculator gives you one answer and moves on. A program can store information, transform it, and use it later in bigger steps. When I assign a value to a variable, Python first evaluates the expression on the right-hand side, then stores the result under the variable name on the left-hand side. The idea is extremely important, and you will use it in every Python program you write. Also, remember that variables can change. This is why they are called variables. If I assign a new value to the same name, Python replaces the old value with a new one. You should also pay attention to naming rules. Variables can contain letters, numbers, and underscores, but they cannot start with a number. They also cannot contain spaces, and they cannot use reserved keys like if. This may seem like a small detail, but clean variable naming makes your code easier to read, easier to debug, and easier to maintain. Now let's talk about output. If I just type a variable name in an interactive environment, Python shows me its value. But in real programs, we often use print when we explicitly want to display something. This distinction becomes useful later when we write longer scripts and applications. Not every value needs to be shown to the user. Sometimes we store values quietly, and sometimes we display only what matters. I'll talk about functions properly in a later session. So for now, just think of print as a built-in command that tells Python to show something on the screen. Next, let's look at text. In programming, text is called as a string. A string is simply a sequence of characters inside quotes. This is why 3 plus 3 behaves differently from code 3 plus 3. The first is numerical addition. The second is a string. Python is very sensitive to type, so the codes matter. When students are new to Python, one of the biggest confusion is something that looks like a number may actually be a text. This is why understanding types early is important. Python works on different types of objects. In this session, the main ones are integers, floats, strings, and booleans. Integers are whole numbers, floats are decimal numbers, and strings are text, and booleans are true or false. We can inspect the type of the value by using type. Later on, when you build web applications, type awareness becomes even more important because user input often arrives as text even when it represents a number. Sometimes we need to convert from one type to another. For example, a number written as text can be converted into an integer using int if the content is valid. Similarly, we can use float and string for conversions. This is a good place to tell you that every conversion will not work. If the value does not make sense for conversion, Python raises an error, and that is perfectly normal. Now we move to comparisons. Comparisons ask the questions such as, is one value greater than the other, equal to the other, or different from the other? The result of a comparison is always either true or false. These Boolean results are what make decision making possible in programs. A program does not think like a human. It evaluates conditions and branches based on whether these conditions are true or false. This leads to conditional statements. An if condition tells Python to execute some code only if a condition is true. An else gives an alternate path, and else if lets us check multiple cases. This is one of the most important ideas in all of programming. Once you can store information and make decisions based on this, you can build logic. That is the beginning of real applications. Please pay attention closely to the colon at the end of the condition and the indentation of the next lines. In Python, indentation is not just a style, it's a part of the syntax. Finally, we briefly look at repetition using while loops. A while loop keeps running as long as the condition remains true. This helps us avoid repeating the same line again and again, but it also introduces responsibility. If a condition never becomes false, the loop runs forever. This is why initialization, condition, and update are three key paths to watch. In this first session, I do not want you to worry about memorizing every operator or every error type. What matters is that you begin to see patterns, values, variables, types, conditions, and repetition. These are the building blocks we will keep reusing. In later sessions, we will gradually move towards functions, collections, lists, sets, working with files, and eventually building a Flask application and automating deployment related workflows with GitHub Actions. For now, the win is simple. Understand how Python executes code and how basic logic is written.